Hello, calculus class. Here is our video for 4.5. But first, let's do a bell ringer. Use the chain rule to find the derivative of the following function. This is not the antiderivative, not the anti, just the regular. Now, perhaps some of you might need a refresher on the chain rule. We called it the orange peel rule. So just a little refresher. To do the orange peel rule, you're first going to take the derivative of the outside, or the orange peel. Then you're going to take the derivative of the slices. And once you have those two derivatives, you will then multiply. Now, what exactly is the orange peel? Think of it as this is the peel, and this is the part on the outside. So this is the orange peel that we have to derive. So let's do that first. Like any derivative, you'll multiply the power to the front, 3 times a third. That will give you 1. And then, of course, that means you'll subtract 1 from the new power to give you 2. Now, remember this part. The x squared plus 1 does not change yet. It stays as x squared plus 1 in this step. Now, in the next step, all of this inside our little parentheses, that's the slices. Basically, the slices inside your orange peel. And that is what we're going to derive next. So derive x squared, you should get 2x. Derive 1, that's just 0. So that is the derivative of your slices. So there you go. You got your derivative of the orange peel, and you got your slices, and now you can multiply. And it turns out really the only thing you can multiply is the 1 and the 2x. So then you can say officially that your derivative is going to be 1 times x, just 2x, and multiply that by x squared plus 1 all squared. And there you go. Just a refresher on the chain rule. But now I got a question for you. What if all of this was not here? Basically, what if I gave you this at the beginning and I told you to find the original? Kind of stumped on there, isn't you? Aren't you? You're probably thinking, okay, I got to do a product rule. But wait a minute, the product rule is for regular derivatives, not antiderivatives. So we're going to have to do a reverse chain rule to find the original function. And how in the world are we going to do that? You only know how to do chain rule the regular way. How do we do the reverse? That's what we're going to learn today. So buckle yourselves in. This is going to be a good one. All right. So reverse chain rule, or basically the antiderivative of chain rule, is what we call integration by substitution, which substitution is basically another word for replacement. The objective is using pattern recognition to find an indefinite integral and use a change of variables to find an indefinite integral. Now, before I begin with the reverse chain rule, we need to talk about change of variables. Or in other words, sometimes there will be a case whenever you have a function that's in terms of the variable x, and we may have to rewrite it so it's in a different variable, like u, for example. This is what will be called, for this particular lesson, u substitution or u replacement. So in other words, what's going to happen is we're going to have something that looks like this. It's going to look really yucky. There's going to be a bunch of parts to it. But using u substitution, we're going to be able to rewrite it to look something simpler. And notice how instead of x variables, it changed to u variables. Change of variables. This may seem a little confusing at first, but once you get the hang of it, you'll find that it will make the integral part much easier. and it will make more sense once I actually show you some examples. So, to show you how exactly we're going to do this. So as of right now, you got an integral, and you need to find the integral of this, or find the antiderivative of this. Yeah, that's a lot. That's a lot to try and find the antiderivative of. You're not even sure where to start, given that I haven't taught you this yet. So, what we're going to do is we're going to first, before we do any calculations, let's label some stuff. For example, I want you to take the blob that's inside the squared, or in this case, take that x squared plus 1 inside those gigantic parentheses. And I want you to do is to take that and label it as u, just like the textbook has done. And now what's going to happen is I want you to derive both sides. Let's first derive this side, x squared plus 1. You derive that, it's going to give you 2x. And while you're at it, go ahead and put a label there, dx. Basically the acronym of saying, hey, this is the derivative of x on this side. And then now do the derivative of u. Well, you guys know the derivative of x, you know that's 1, right? If you do the derivative of u, still a variable, you derive that, that's still going to be 1. So in other words, when you derive u, you're going to get 1, but you're also going to give it a label. Or in other words, saying, hey, derivative of u. The derivative of u is right here. And of course, the textbook, when they do 1 times du, they basically just say, hey, just label that du. It's basically the same thing as 1 times du. So just so you know. But once you have these two labels, these are the most important tools that you're going to use to help derive this. What's going to happen here is we're going to be taking the u and du, and we're going to substitute or replace these into our equation, and that will help us derive. I'll show you what I'm talking about in the next slide, just so you get more feel for it. So, same function. Let's do exactly what we just did. Let's take the giant blob inside the parentheses, x squared plus 1, and we're going to label that u. Okay, then let's derive both sides. You derive the right side, you're going to get 2x, and then label that as dx, or in other words, derivative of x. On this side, derive u to get 1, and then label that as du, derivative of u. But of course, 1 times du, you can go ahead and just put that as du. It'll make it easier. So now, we have our key components. Now let me show you how we're going to use them. So back to my original equation. So I have the integral, and originally I have x plus 1 squared. But I'm not going to write x plus 1. Instead of x plus 1, I'm going to put it as its equivalent, u. X squared plus 1 is the same as u. So for now, I'm going to substitute u, or replace it with u, in this spot. But that's not the only thing we're going to replace. Here, we have 2x dx, which as you see here, 2x dx has been labeled as the same thing as derivative of u. So I'm going to replace 2x dx with du. So right behind there, I'm going to put du. So in other words, I've replaced the x squared plus 1 with u, and I've replaced the 2x dx with du, using these key components over here. So in other words, by doing that, we now have u squared du. Now, as you have just seen, the variables have now changed. We've started with x, and by doing this, we have now replaced or changed the variables with u. It may seem confusing at first, but now that it's rewritten like this, it is much easier to derive, because you all kids, you students definitely know how to derive a variable squared. Let's go ahead and do it. To derive u squared, you add 1 to the power, which will give you u cubed, and then you divide by your new power, which is 3, and then plus c. And there you go, that's your derivative. Well, that's 99% of your derivative. Because you see here, we only used this letter u to help us do the antiderivative. But now that we have the antiderivative, we don't need that u anymore. We can put back the original part. Or in other words, we don't need u anymore. Let's get x plus 1 back. So in other words, let's put x squared plus 1 back where the u was. So x squared plus 1 cubed, all divided by 3 plus c. And just like that, you have the official antiderivative or integral. So in other words, this is your answer. Another way to rewrite it, you could take the division of 3 and rewrite it as 1/3, and then multiply by x squared plus 1 cubed plus c. Both of these are acceptable. Now, real quick, you guys probably recognize that this was, you guys probably recognize the x squared plus 1 squared 2x. That was the answer from your bell ringer, right? And didn't I ask you, what if you started with that, how would your original function look? It should look like this: 1/3 x squared plus 1 cubed plus c. Let's take a look. Let's go back to the bell ringer. Oh my God, it is 1/3 times x squared plus 1 cubed. But of course, the plus c, but you guys didn't know that the plus c was 0 back then. But you know it works. This works, because it just got you the original function from the bell ringer. Nice. All right, let's do a couple more examples, just so you can get the feel for it. Let's try this one now. So again, it wants us to do the integral, which means we got to do the antiderivative. Right now, that's a lot to do the antiderivative of. So let's break it down. Let's take the giant function inside the parentheses, 5x squared plus 1, and let's replace it, or let's set it equal to u. Now let's derive both sides. If we derive the right side first, 5x squared will become 10x. Derivative of 1 is just 0. So you just get 10x, and then you'll label that as dx, derivative of x. Now derive the left side, derive u. Derivative of u is just 1. Label that as du, the derivative of u. But of course, 1 times du is just du, so you can leave it like that. All right. So now we got the key parts we need. Now let's fill in the blanks. Well, first, our integral has 5x squared plus 1 squared, but instead of 5x squared plus 1, I'm going to substitute u into its place because of this. So instead of 5x squared plus 1, I'm going to use u. And that's not all. Here I have 10x dx, which is the same as what I got right here. So I can replace all that with du. So go ahead, replace that with du. So in other words, that gives us the integral of u squared du. And if you look at that, that is very much easier to derive. Well, I meant antiderive. You can find the antiderivative of this. So let's do it. Antiderivative, u Add 1 to the power, which gives you 3, then divide by the new power, plus c. There you go. There's your antiderivative. However, you don't leave it as u. You only used the u to do the anti. And now you have done the anti, so you don't need that u anymore. Instead, put back what u originally was. And u was originally 5x squared plus 1. So go ahead and put 5x squared plus 1 in its place, and you officially have the antiderivative. And if you formally want to write that, you can take 3, pull it out as 1/3 to get 5x squared plus 1 cubed plus c. And there you go. All right, so basically those two were very similar tactic. Why don't you go ahead and take a shot at this one on your own, trying the same tactic. Go ahead and pause the video and try it now. And then whenever you're done, watch what I do, see that you got it right. Go ahead, pause it now. Okay, you should have resumed the video by now. We're going to go ahead and do it. Oh, give me a sec. Gotta let this play through. Some of you are probably laughing to yourself hearing me sing to that. But anyway, moving on. If you want to just quickly check your answer, this is what you should have gotten. You should have gotten x squared plus 1 to the 5th power all over 5 plus c. Or, in other words, 1/5 to the x squared plus 1 to the 5 power 5 plus c. That is what you should have gotten. Now, if you want me to walk through it, I'll do it in a second. If you just want to check your answer, you can go ahead, skip through this, move on to the next problem. So, just to show you how it's done. Again, take the big blob inside the parentheses, x squared plus 1, and we're going to set that equal to u. Take the derivative of the right side, you should get 2x, label that as dx. Take the derivative of the left, you're going to get 1, and then label that as du, derivative of u, but we don't really need that 1. Now, some of you might have got stumped on the fact that 2x is not where it should be. It should be in the back, but it's in the front. But to be fair, this is multiplication. You don't really need that 2x to be in the front. You can rewrite it so that, you can rewrite it so that you can move that 2x right next to the dx, and it will make things easier for you. So now, instead of x squared plus 1, I'm going to replace it with u, because this tells me I can. And then the 2x dx, I'm going to replace with du, because this tells me I can, because 2x dx is the same thing as du. Moving on from there, you'll have the integral of u to the 4th du. Now you can do the antiderivative of u to the 4th. So let's do it. Should have u to the 5th, because you add 1 to the power, then you divide by your new power, plus c. All right, your antiderivative is done, meaning you don't need that u anymore. You can put back in the original function, which was u was originally x squared plus 1. So x squared plus 1 to the 5th all over 5 plus c. Or, in other words, 1/5 x squared plus 1 to the 5th plus c. And there you go. Now there's one more example that I want to show you real quick before we take it up a notch. Now this example, some of you might be freaking out because you see the square root. But never fear, 3x squared in the front. Remember, you can take that root and rewrite it as a power of 1/2, x cubed plus 1. Because the power, or not the power, the root is 2, and the power of all this is 1, power over root. All right, so you guys are familiar with that. But now, we gotta start deriving it. And also, while we're at it, I'm gonna go ahead and move the 3x squared to the back. So that's gonna give me x cubed plus 1 to the 1/2, 3x squared dx. Okay. So now, I'm going to go ahead and take the 3x squared, or the x cubed plus 1, label it as u. Then derive both sides. On the right side, I'll have 3x squared, and then label that as dx. On the left side, the derivative of u is just 1, and then label that as du, which you guys can just put that as du. So that's what we need to help simplify this problem. So, start off, I'm going to replace the 3x, or the x cubed plus 1, I'm going to replace that with u, because that's what this says right here. And then I'm going to replace the 3x cubed dx with du, because that's what it says right here. The 3x cubed dx is this, they match, which should be the same as du. Okay, so in other words, I just got u to the 1/2 du, that's all I gotta derive. So let's go ahead and derive that. Just like before, you gotta add 1 to the new power, but we should rewrite that 1 as 2 over 2. So 1/2 plus 2/2 will give us u to the 3/2. And then divide by that new power, 3 divided by 2. And that will give us plus c. Moving on from that, we probably should rewrite the division of 3/2. Let's rewrite it as the multiplication of the reciprocal. Dividing by 3/2, the same thing as multiplying by its reciprocal 2/3. And that's going to be multiplied by u to the 3 over 2 plus c. Now, we don't need this u anymore. We have just done the antiderivative, so we don't need that u anymore. Let's replace it with its original, x cubed plus 1. So over here, I'm going to have 2/3, parentheses, 3 over 2 plus c. But in the parentheses, I'm not going to put u. I'm going to put x cubed plus 1. And there you go. We are 95% done. Oh, we're not done yet. We still got another 5% left to do. And you could probably guess what it is. We started with the root. So we gotta end with the root. So we're gonna rewrite it in root form. The bottom number is the root, so it's gonna be square root. The cube is the power. So all of this, x cubed plus 1, all to the power 3, and then plus c. And that is our answer, 100% done. All right, so that's the introduction to U substitution. Your first assignment is page 304, numbers 7 to 10. Now, I'm going to keep continuing with the video. This lesson, or this 4.5 lesson, was supposed to be 2 days. I'm going to continue with the lesson from here. If you want to keep watching it, good. If not, if you want to take a break, finish this assignment, and then come back to it, that's up to you. But I'm going to keep going. Now let's take it up a notch. What about this example? Well, you learned from the previous example that I can rewrite this square root to make it easier. So, integral, I'm going to rewrite this as parentheses power 1/2, root of 2, power of 1. And on the inside, we'll have 2x minus 1, and then we'll have dx. Okay, so trying to find the antiderivative of this. Doesn't look pretty. But again, let's use our u substitution tactic. Take the inside, 2x minus 1, and we're going to label that as u. Then let's take the derivative of both sides. Derive the right side. Derivative of 2x is just 2. Derivative of negative 1 is just 0. So our derivative is 2, and we're going to label that dx, derivative of x. And then derive the next side. Derivative of u is going to be 1, and then just label that as du. But you guys can probably guess at this point that this is always just going to be du when you do this part. All right. So now, I'm going to start plugging stuff in. You're going to realize in a moment that something's not going to quite add up. All right. Get the parentheses 1/2. I'm going to take the 2x minus 1. I'm going to replace that with the u, because this is what this says. U and 2x minus 1 are the same thing. But now, wait a minute. Here I have dx. But my blue sentence over here has a 2 dx. Not just dx, a 2 dx. So these two parts don't quite match. So what do I do? What do I do? Well, if I just had dx, then I would be fine. If I could just get rid of this 2 somehow, I'd be fine. Could I get rid of the 2? Maybe if I divide it to both sides, then on this side I would have 1/2 du, and then over on this side the 2 would cancel, and all I'd have left would be the dx. If I do that, If I do that, then these two parts would match. So then with that said, I could take the 1/2 du and put it in place of the dx. So there you go. And then that would give me the integral of u to the 1/2 times 1/2 du. Now some of you are probably wondering, cool, Miss Shulin, how can I take the antiderivative with the 1/2 in the way? Well, never fear. There is actually a calculus rule that says that you could put the 1/2 outside the integral. So 1/2 and then the integral of u to the 1/2 du. So then all you got to do is do the antiderivative of this, and then the 1/2 will come in later in the final answer. For example, for right now, the 1/2, let's leave it on the outside. But right next to it, let's do the antiderivative. So in other words, add 1 to the new power, or 2/2. You should get u to the 3/2, then divide by that new power, and then plus c. Continuing over here, the 1/2 still on the outside. Take care of the antiderivative. The 3/2 being divided, change that to multiplication of its reciprocal, 2/3. And that's going to be u, or that's going to be multiplied by u to the 3/2 plus c. So now, you got 1/2 and you got 2/3 here. At this point, you're allowed to multiply those together. Multiply on top, you get 2. Multiply on bottom, you get 6. And then you reduce. And that will give you 1/3 times u to the 3/2 plus c. But remember, we're not done yet. We just did the antiderivative. So in other words, we don't need this u anymore. We're going to need to plug in back the original function. And what was the original function of u? The original function of u was 2x minus 1. So here, 2x, oh, I'll write that in red. So instead of u, put 2x. And was it plus 1 or minus 1? It was minus 1. Okay. So there you go. We are 95% done. The other 5%, you gotta rewrite it as a root. So let's go ahead and rewrite it as a root. So here, our root is 2, so square root. And then our power is 3. So 2x minus 1, so the power of 3 plus c. And that is our official integral, or antiderivative. So that one was a little bit weird, mostly because originally the dx here didn't match up with the dx here. So we had to do a little division to make it work. But everything else stayed the same. Let's do a couple more examples just so you can get familiar with those types. Oh, and also on the next couple of slides, here's the textbook's version of doing exactly what we just did. And you'll see that we will still have gotten the same answer if you followed their steps as well. That's there for reference whenever you need to see it. All right, so now let's take a look at this. So for starters, I'm going to rewrite the integral so that the x is with the dx. So now I'll have x squared plus 1 squared, and then I have x dx. And to start off, I'm going to take everything inside the parentheses, x squared plus 1, and I'm going to label that with u. And then just like before, derive both sides. If you derive the right side, you'll get 2x, and then you'll label that as dx. Then derive the left. Derivative of u is 1, label that as du. But again, you don't need to put the 1 there at that point. Just put du. All right. So now let's do some substitution. So in the parentheses squared, instead of x plus 1, I'm going to put u, because x squared plus 1 is the same thing as u. And now I need an x dx. Here I have an x dx, but I'm not supposed to have that 2. So to make it match, I'm probably going to have to divide that 2 to both sides. So on the left side, I'll have 1/2 du. The 2's will cancel over here, and I'll have x dx. Now this matches with that, so now I can put this in. So in other words, I can replace that with 1/2 du. And just like before, if you don't want to deal with the 1/2 just now, go ahead, just take your 1/2, put it to the front for now. So in other words, 1/2, and then integral of u squared du. All right. Now we got something we can take the antiderivative of. Easy peasy. Let's do it. So we still have the 1/2 on the side. Now let's do the anti. You add 1 to the new power, which gives you 3, and then divide by the new power, which is 3. And then you got to add your constant. All right, we're done with the hard part. Now we just got to simplify. So 1/2. The division of 3 can be rewritten as multiplication of 1/3. And by doing that, the 1/2 and the 1/3 can multiply. And that will give you 1/6, u to the cube plus c. But now, officially, the antiderivative is done, so I don't need this u anymore. I can replace it with its original function. And what was its original function? The original u was x squared plus 1. So replace the u back with x squared plus 1. And that would be your antiderivative. And double check, did we start as a root? Nope, we started with the regular power. So we end with the regular power, which means we are good to go. We have our antiderivative. We are done with this example. Okay, I want to see how many examples we have left. Oh, forgot about that. So you see this example? This example is also done on this slide, and they go through a step-by-step example, and you'll see that we got the exact same answer that we got on the previous slide. Awesome! All right, we got 2 more examples to cover, and then we'll be done. I want you to take a shot at this one. This one's actually not that different from the previous one. Go ahead and try this one on your own, and then we'll double check. Go ahead and pause the video now while I go grab a cough drop. All right. Again, this one is basically almost identical to the previous one. So I feel like I'm not really going to work through this one, but I will tell you the answer. So for the answer, you should have x squared plus 1 to the power of 5, and then all that is going to be divided by 5 plus c, but then you are going to end up with a 1/2 in the front. So then that means when you simplify, take the division of 5, rewrite it as 1/5. That will make it so that you have to multiply the 1/2 and the 1/5, and that will give you 1/10. So your official answer should be 1/10 x squared plus 1 to the 5th plus c. If you need me to work through that one, please email me or message me on Google Classroom, and I'll talk you through how that one needs to be solved. But again, it's almost identical to the previous one we just did. So with that said, I got one more example to show you, and then we'll be done. All right, this one. Before we do any u du stuff, I'm going to go ahead and rewrite this so that the x squared is in the back. And also, I'm going to change that root. Excuse me. Darn allergies. Okay. X cubed plus 1, I'm going to rewrite that as 1/2 because of the root. And then the x squared, I'm going to move to the back. So we have x squared dx. Okay. So now to solve this one, I probably need to do some u substitution. So I'm going to take the stuff in parentheses, going to label it as u. Okay, take the derivative of the right side. Derivative of x cubed is 3x squared, and then label that as dx. The derivative of the u on the left side is 1, and then label that as du, which 1 times du is, again, just du. Okay, looks like we got the information we need so far. Okay. So here I'm going to have the parentheses 1/2, but instead of x cubed plus 1, I'm going to replace it with a u. So u to the 1/2. And then I need something here to replace x squared dx. Here I have x squared dx, but I have the 3 here. Probably similar to how I divided by 2 to the previous examples. I'm going to divide by 3 this time to both sides. So that will give me 1/3 du, and then the 3 cancels over here, and I just get x squared dx. And check it out. X squared dx, x squared dx. These match. So now I can take the 1/3 du, put it in its place. So replace this with 1/3 du. And then go from there. Let's go ahead and take this 1/3. Let's move it to the front. So then that's just 1/3 integral, u to the 1/2 du. Okay, now we have a much simpler example that we can easily take the antiderivative of. Let's do it. Remember, you still got your 1/3 in the front. Leave it as is. But now let's take the antiderivative. So we'll add 1 or 2 over 2. So 1/2 plus 2/2 gives you u to the 3/2. Then we're going to divide it by our new power. 3 divided by 2, and then plus c. Now we just got to simplify from there. Make some more space. So 1/3. Let's rewrite the 3/2, the division of 3/2 as the multiplication of its reciprocal. So 2/3 u to the 3/2 plus c. But now we can multiply these two fractions in the front. If we do that, you'll get 2 on top, 9 on bottom. So 2/9 times u to the 3/2 plus c. All right. We have done the antiderivative, which means we don't need that u anymore. So instead of u, I'm going to replace it with its original function. And u was originally x cubed plus 1. So x cubed plus 1, and then plus c. All right. Now, one last thing to check. Should we leave it as 3 over 2? Let's take a look. Nope, we started as a root, so we need to end as a root. So then, for our final answer, 2/9 times the root is 2. So square root of x cubed plus 1. The power is 3. So that's going to be to the power of 3, and then plus c. And congratulations! You are now very confident and very knowledgeable in u substitution. And it's very helpful to finding antiderivatives of more complicated examples. On the next slide, here are just some step-by-step instructions for substitution if you ever need just reassurance in the future. And I do also want to check, just want to let you know, if you ever have any doubt about if your answer is correct, you can always check by taking the derivative of your answer. You just got to do the chain rule on it. And if you do the chain rule and if you get the same answer that you started with at the very beginning, you know you have the right answer. So, with that said, you now have 2 assignments that are due at the end of the week on Friday. Make sure to send them to me via email or send them to me via Google Classroom. You have yourselves a lovely week, and I hope to see you again soon. Ta-ta!